class now. For those who are joining and haven't scanned the attendance, don't worry, I will share the QR attendance later before we end the class, okay, today. So yeah, okay, let's get started. Okay, if you see from the ELIP, I have uploaded lecture 3. So I think I do mention last week that we're going to skip lecture 2 first. Okay, we hold it for later because it's lecture 2 only a basic calculation like numbering system, how to convert binary to decimal, decimal to binary, hexadecimal. So this can be whole, maybe I will finish until lecture 4, then we go back to lecture 2, okay? So for your midterm, it will covers from lecture 1 until lecture 5. Okay, take note na, untuk midterm awak akan lecture 1 until lecture 5. But before the midterm break, we have planned to cover until lecture 7. We see how it goes. Okay, maybe kita akan sempat habiskan lecture 7 ataupun 6. We see how it goes. Okay, let me. Okay, kita start lah. Okay, boleh tak I get some response? I hope you guys can hear me. Semua okay?
Yes, can hear you, madam.
Okay, let's do some recap before we start with lecture 3. Okay, lecture 3 is computer function and interconnection. Okay, as you know, it's a part of one of the main component of your computer. So kita recap. So you have, in order to make a computer, they must have these 4 main component other than 4 main function. Apa 4 main function dia? Data processing, data movement, control, and satu lagi apa? Ada 4 kan? Storage. So this is orang kata function that computer must have in order for you to call it a computer. Sebab tu dia tak boleh panggil seperti sejuk, rice cooker, no matter how smart they are not computer because they must possess these 4 main function. Yang tadi itulah movement, processing, storage, and control. So for the architecture, okay, aligned with our course kita computer architecture, right? And last week we have discussed and asked you guys to give the definition of architecture. Saya bagi contoh rumah. What make a house? What make a building? A structure they can call it a house. There are the roof, there are the walls, ada foundation, ada flooring. So it's a structure. Same goes to the computer. Computer kena ada certain structure or architecture. See? You combine it together, then you can call it a computer. Itu yang dipanggil Mickey Mouse tu. So you have 4 main component. Okay, can you name the first component, guys? What is the first component? What first component?
CPU.
Okay, CPU. Okay, it's a CPU. Okay, lagi?
Main memory.
Main memory, good. What else, Naim?
Input and output.
Okay, input and output module. And how they communicate? Through what? Yang lain, tolong cepat. System bus, right? So maybe you can use a mic because sometimes I cannot look at the chat box while I'm scribbling. Okay, so system bus is a system interconnection. Okay, remember they not talk directly. These 3 components they cannot talk directly. They must through system bus. The function of the system bus is to exchange the data, the status, the control, and the signal. Later on kita akan tengok. So this is the 4 main component of your computer. Dia mesti ada this component. Otherwise you cannot call it a computer. Okay. CPU, you know, is a processor. Okay. Kita bagi contoh is a brain. Okay. Brain, what our brain do is to process information. Kan input lah. Dia kena ada input then you can process to produce an output, right? So this is your CPU, or you can call it processor. Okay. And then you have main memory. Okay. It's a primary memory. Or you can call it RAM. It's the same thing. Dia dah banyak nama, tapi dia primary memory. So this is your RAM. And then it's an input-output module. When you see I/O, it doesn't mean it's a devices. The device, your external device, your internal device will be connected to this module or program. Why? Because we have different type of devices kan. Kita ada input, kita ada output, and there is different brand, different manufacturer, different specification. So they will plug in into this component. Okay, and then if there is any data exchange between this component, they must through bus. Contoh bus kita bagi last week is a unite bus. So the bus that we have is to carry people kan. So the bus they carry apa? They carry data, they carry signal, and they carry control line. So dekat ni ada line lah. They have their own line. So it will communicate. Dia tak communicate directly. It's because our computer have different component. So dia kena lalu bus. Okay, it's transportation lah. Dia macam transportation to transport the data, status, signal, control. Okay, and also address. Okay, and then okay, yang ini for today we will look at the in general. The computer first part is computer function. Okay, first part we look at the computer function, and the second part will be system bus. So untuk lecture hari ni akan ada dua. Kita akan tengok these two component lah. First part kita akan tengok what is the computer function in general. It's fundamental. Okay, let's me share the our apa? Ni. All this PDF. Okay, maybe you can refer to your PDF lecture 3. Kat sini, sekejap ya guys. Salah, sorry. Okay, let me share PDF. Okay, lecture 3, siapa yang baru masuk is lecture 3. We skip lecture 2, jangan terkejut, tiba-tiba ada lecture 3. So guys, okay, computer function and interconnection. If you see the word interconnection is a system bus. Or PCI is the same thing. Peripheral computer interconnection. Okay, it's the same thing. Okay, the top level of memory consists of memory processor, memory I/O component. Okay, the functional behavior of the system consists to exchange of data, and consumption among these components. Dia kena ada exchange of data through system bus. Okay, to support this exchange, this component must be interconnected using system bus. Okay, you ingat the my key mouse ni. This tree is not interconnected, so you interconnect using the system bus. So di sini dia akan ada line to exchange data between these three main component. Okay. Okay. What is the monument architecture? Okay, just now the what I have shared is a monument architecture that make our computer today. Okay, there are this format component is based on the monument architecture. Monument is a reference name. Okay. Data and instruction are stored in single read and write memory, okay, dalam RAM. The content of this memory are addressable by location. Okay, this is the important information. The content of this memory are addressable by location without regard the data type of the data content there. So can you imagine this is your memory? Kita bayangkan memory macam ni ya. This is your main memory. Okay, you can see I'm scribbling guys. Nampak tak yang warna merah ni? Can anyone respond?
Nampak.
Because pernah dalam kelas, tengah lecture, habis lecture baru student tak nampak saya scribble, okay? Okay, ini adalah memory. Imagine this is your main memory. So what is mean by addressable by location? Each of the data inside this memory, katakan inside each line of this memory, katakan data, or program, or instruction. So dia kata addressable by location. They have their own address. Okay, for example, start with 1, 2, and is in sequentially fashion. 3, 4 until and is a number lah. For example, we don't know what is the size of this memory. So it's addressable by location. So it can contain data, it can contain instruction, it can contain program. Okay, if you see the word here, dia kata without regard to the data type. Dia tak kisah apa dalam, tapi semua kena load dalam ni. For example, when you switch on your computer, sebab itulah last week I asked you what is the one of the characteristic of RAM. Is it volatile or non-volatile? Volatile ke non-volatile? Okay, it's a volatile, meaning if there's no power kan, if you shut down the computer, what happened to the data retained inside this memory? Jadi apa guys? What will happen to the data? Hilang kan, dia release the data. So that's why when you switch on your computer, it takes a while. Because a while mean like 1 second, depending on your how the spec of your computer. So because they need time to load, they akan load operating system, they akan load necessary program for when they booting up. Okay, nah macam tu lah. When you switch it off, they release balik. Sebab sometimes people they don't switch off their computer, they will put into the sleep mode to save some time. Okay, so this is the memory lah. So dia temporary storage. So bila you masukkan macam-macam dalam OS kan, so how do they arrange? So they put inside this addressable location, line in line. So ada data lah apa-apa lah So nanti yang memory management is another topic. This will covered in operating system course next semester. Okay. Dekat sini you cuma perlu faham that each of the data adalah disimpan di dalam each line. And setiap line memory ada address. That's how the CPU know where to get the data. Okay. This will bring back the function of the CPU. Okay. Faham ni ya? Okay, contoh ni macam ni. The RAM. Ini RAM guys. This is the CPU. This is the component inside the CPU. Kita ada ALU, kita ada CU dan register. Banyak lagi ya. This is just Monument punya general architecture. So this is your I/O module. So all the I/O will be connected to this module. So RAM, all the data instruction will be loaded into RAM. The CPU, as you know, is the process. At this stage, you must know what is the function of the CPU. Okay, you already know lah, function of CPU to process. What are they processing? Instruction they given to the CPU, that what are they processing? They akan process lah. But then you know characteristic of RAM. All the data instruction must be loaded into RAM first. Semua data, semua must be loaded into RAM first before they can be processed by CPU. Itu yang tadi kita tahu data processing, data movement, function dengan control. If you go back to lecture 1, in one of the slides it says data must be stored inside the RAM even on the fly, walaupun sekejap. Kan, dia kena load. It's not goes directly to CPU. What CPU did, they will fetch the data or instruction from RAM. Dia akan fetch yang dia ambil and brought it back to CPU to be processed. Okay, dia akan decode dan execute. And this process will be in cycle lah until it's completed and finished. Okay. Okay, hari ini kita akan tengok yang ini. Alright, ini. Okay, the general purpose of architectures. Okay, the primary function of CPU is to execute. Kerja dia execute dia, to process the instruction that fetch from main memory. Dia kena ambil daripada main memory. Contohnya our brain. Our brain is, we have our own CPU inside your brain is the CPU. In order you to process something, you must have input, right? So where you get the input from? From the part of your head, kepala kita ni, there's a, I don't know what you call it, ada certain part yang called the memory. So you must process from that memory, from the input. Dia kena ada input. Dia masuk dalam memory dulu, then it can be processed. Okay. An instruction tells the CPU to perform one of its basic operation. It's either arithmetic or logic operation, depending on what the instruction telling them to do. Dia akan decode dulu. CPU will decode. Dia akan translate what this program tell them to do. Kan? There's another story lah. Okay, the CPU is the one which interprets. Okay, one of the function of the CPU, remember that I said it's a brain of the brain. Brain of the computer is will interpret ataupun another word is decode. Dia akan decode lah. Dia nak apa? Okay. Okay, to be executed and which tell the different other component what to do. If they involve another component, it will tell. Okay, you need to go to I/O. You need to go back to main memory to get this data. Contohnya. So dia akan translate. Okay. The CPU also include a set of registers. Ingat tak set of registers adalah a temporary storage. Okay, to hold the address, to hold the data and so on. Which a temporary storage typically used to hold intensely used data and intermediate result. Okay. Kita akan tengok yang ini ya. Okay, ini kalau program konsep if the hardwire you need to rewire if you need to change it. Contohnya you want to do the partition. Using software, you don't have to physically wire it. You just use the program, okay? What is a program? Basically, it's a sequence of steps. For each step, an arithmetic or logical operation is done. It's a sequence, yang ni penting, a sequence of steps. Okay, it's a program. For each operation, a different set of control signal is needed. For example, signal adalah read, write, add, move, and etc. Nanti dalam lab you akan buat sikit lah. It's a very basic orang kata operation using assembly language. Okay. And next one will be ini contoh lah functional of control, add, move. Okay, a hardware segment accept the code and issue the control signal. Okay, we have a computer. Okay, let me read. Okay, this one already. Okay, storage of code. The storage of code and result is needed. You can get from the main memory. Remember, it must be loaded into main memory first before CPU can execute. Yang ini penting lah. If you get this, kata very basic information and knowledge, it's easier for you to understand the rest of the lecture sampai habis kursus ni dan juga for operating system. Okay, dia fundamentally senang je. You kena tahu apakah function CPU to process. When they want to process the input, dia kena ada data. Where they get the data from? From main memory. Jadi is main memory. This is CPU. In order for them to execute, they need to fetch from memory and write back to the CPU to be processed. Dan dia akan decode. Katakan decode, dia kata, oh, you need to store back into memory, then it will be brought back, and dia akan store the data back to the main memory. Itulah, depending on the instruction. Faham tak bahagian ni guys? CPU and memory, how they works, how they interrelated. Got it? Okay, good. Faham kan? Kan simple kan? You just fahamkan CPU, they execute instruction. Where this instruction from? From main memory. Semua mesti masuk dalam main memory first. It's not directly to your CPU. Sebab itulah when you buy the computer, you must the specification yang usually people macam look after, yang focus on is CPU and RAM. Okay. Okay. Ini contoh CPU. Before we go back to this, ini contohnya actually this is the same thing what I have just explained now. So CPU, when you have your memory, ini addressable location. Each of this data ke instruction ke, you kena store in each memory. Kita panggil memory line. So for each of the memory line, they has their own address. Inilah sampai N. Okay, you can see here is the system bus. Is how they interchange the data between the three main component. Remember, it's very important information. They not talk directly. They must through system bus. Okay, and then this is the partial part of the CPU. You have PC, you have IR. Okay, ni tak nampak pen saya ni. Okay, this is CPU. Yang nanti this one I will explain later using example, so it's easier to understand. So we have program counter, MAR, MPR, IO, IO. Okay, yang saya nak explain pasal ni. This is IO module. So the CPU also can talk to the IO depending on what instruction telling them to do. Okay, but in order for them to execute, they will get from the main memory first. Okay, dia akan decode. Katakan after they decode the instruction set write to IO, then they will go to IO. Macam itulah. So let's focus on what is MAR, what is MBR, IOAR, IOBR. So this has the same function for memory address register. It's the same function with input and output address register. It's just different component. Okay, function dia sama, cuma tempat dia lain-lain. So for example, if the CPU fetch the data from main memory kan, lepas tu dia brought back to the CPU. So the address will be stored here. The address akan di store dekat main memory address register. If they get it from the IO, it will store in IO. Memory buffer register, buffer you know right, to retain the data, to store the data. So the buffer from this address, the data from this address akan disimpan dalam ni. Katakan saya ambil dekat address nombor 3 contoh So what in my memory address register is adalah 3 and whatever data content in address 3 will be stored here. Why? When they go to the system bus ada line, 3 line. Satu data, satu address, and another one is control, signal. So data ni akan masuk dekat MBR. Address ni akan masuk dalam MAR. So sama function dengan IOR, IOBR. Sama function, tempat je lain. But the function is the same. Yang PC and I will show, I will explain later with example. Okay? Yang ni faham ah? Konsep dia you kena tahu memory line ada address. In order for CPU, when they want to fetch the instruction, MDR, mana MDR? What MDR? I think I just explained just now what is MAR and what is MDR. Okay, in order for the CPU to get the data from memory, they will look at the address. Okay, katakan dia kata address 300, so they'll go to address 300. Let's say the PC now is 300, 3, yeah. So the CPU will fetch from address number 3. So they'll get the address number 3. So lalu sistem bus, MBR ni is a buffer. Buffer, what's buffer do guys? Tengok balik semester 1 awak, what is the function of buffer? To hold what? To hold data kan? To hold data from this instruction tadi ni yang you ambil ni. So katakan dalam instruction, so here will be the instruction. Dan here nombor 3 dah. Okay, you just got it? Faham tak? Boleh faham? Okay. MDR tu saya kena check. Memory data, maybe it's the same thing. Maybe it's the same name. Maybe it's the same thing, yeah? MDR, but we're using MDR, memory data register. Is it memory data register? What? Because ingat tak masa lecture 1, I said our lecture note is based on William Stelling. Memang nanti you akan ada a few words, I cannot remember, a few words, dia lain sikit but function is sama. The term is slightly different but the function is the same. Okay, thank you Guan. I will look up into it later. Sebab ada satu pun ada yang lain. Nanti dah ada contoh, beberapa contoh, nanti ada a little bit different in this in terms of the term. Okay. Memory buffer tu to hold the data. Alright. Thank you for that. Kenapa tak boleh bergerak? Hang on, I need to. Alright. Okay, the basic function tadilah. What is the basic function? It's to fetch, processor, read instruction from memory. Okay, ini is a very important, one at a time. Yeah, ini important now, one at a time. Even though it seems to us that CPU processing many things at one time, but actually it's one at a time. It's just that they're very fast. We didn't realize it. Dia sangat laju, like in nanosecond ke, picosecond ke. So it's very fast. It seems to us as user, it's happening at one time. But actually CPU, they only can read or execute instruction satu saja at one time. Tapi the context switching, they're very fast. It seems to us it's happening at one time. Tapi dia allow multi-programming lah. Maksudnya the CPU can switch from one program to another program. Dia boleh. Kalau zaman dulu, kalau you baca lecture 1 tu, only one program at one time. Lepas habis, then you only can execute another program. But now, no. You can open many program, many application kan. It can run at the same time. But while you opening it, the CPU will switch to that program. Dia akan switch back ke sana ke sini lah. Macam tu. Okay, CPU ni function ni dua je, fetch and execute. That's it, processing. Execute, fetch from memory, execute, then brought it back to memory or IO depending on the instruction. Okay, the instruction execution may involve several operations. Okay, ni hang on, saya title lagi. Ni tadi ya, definition ni kalau you nak tengok dalam wording dekat sini lah. Specify the next address of read and write. Wanted the data to be written to memory or receive data from memory. Inilah dia punya definition. Okay. Ini penting lah, gambar ni sangat, this image figure is very famous. Okay, in your exam, in your midterm, also in order for you to understand the concept of the computer function. Okay. Okay, start. Dia fetch the instruction. Dari mana dia fetch guys? Daripada memory. Oh, this pen tak best lah dia tak. Because I'm writing on my tablet. The tablet ni dia tak synchronize. Sorry for the. Okay, dia akan daripada fetch daripada mana? Memory. After that, it will back to CPU and execute. Kalau it's involve several operation, they will cycle lah sampai habis. Kalau habislah completed. Okay? Okay, ini kena ingat lah. Okay, then we go to PC and IR. Tadi tak explain kan, what is PC? PC is a program counter. Bukan pancake ya, program counter. Ada yang tak makan lagi ke? Tak makan semua? Bagus, jangan ngantuk Selalunya tengah hari ni ngantuk. Okay, anyway, let's start. Okay, program counter to hold the address of the next instruction. Okay, kalau you tengok definition dia seolah-olah macam memory address register kan, dia lebih kurang sama je. Cuma MAR dia tak automatically increment. PC automatically increment. Increment by how many? 1. Okay, kalau you buat program dia akan buat macam ni lah selalunya. Mana ni? I plus ke plus 1 I ke, maksudnya increment by default and increment by 1. By default, remember the word by default. Okay, increment PC unless told otherwise. Unless told otherwise meaning they give instruction, different instruction, then they will not increment by 1. Ini usually associated with interrupt. Okay, ini akan later on. Okay, processor fetch instruction from memory location pointed to by PC. Okay, to by PC. Okay, katakan PC tu, we go back here. Example, this PC is pointed to address number 3. Okay, katakan dia, okay lah, address number, contoh number 5. Address, remember the memory dia addressable location. Okay, the CPU will look at PC. Oh, saya nak pergi mana? Dia kata, where should I go? I need to fetch data. This is my function. Okay, go to address number 5. Where? From memory. So dia pun berjalan lah, bukan dia berjalan lah kan. Dia naik bus, dia must know where to go. To location number 5. Okay, dah dapat location number 5. Kan kerja dia fetch. Dia ni macam Grab. You ingat Grab driver je. Kalau you nampak Grab driver tu panggil dia CPU. Okay, dia fetch. Apa dia fetch? Dia fetch data lah, dia fetch instruction ni. At this point, CPU doesn't care apa dalam location tu. Data ke, instruction ke, dia tak kisah, ataupun just operand, dia tak kisah, dia ambil je. Okay, dia ambil je. So dia akan bawa the data that in this address, dia bawa balik dia naik bus lagi. Okay. Baru dah dia akan letak dalam MBR data tu, isi dalam tu, and then MAR tadi kan nombor 5 kan. Macam kan. At the same time, what will happen to PC guys? Remember, it's increment by 1. Pas dia buat operation dia, automatically dia akan increment by 1. So 5, lepas 5 berapa guys? Pandai Rebecca, nah. Oh, Patrick pun pandai kena. So, lepas dah, what CPU will do? CPU buat apa lepas dia dapat location dia? What will the CPU do? Fetch pergi kat nombor 6 tu, dia pergilah, dia dapat order. So dia pun pergi, macam dia order Panda. Mahal sekarang Panda. Semalam saya nak order, mahalnya. Semalam I got class at 12, so tak ada masa. So dia pergi nombor 6, dia jalan naik bus. Dia kena naik bus kan, dia tak boleh melompat, dia kena naik bus. Ada line dia lah, ada address line. So address nombor 6 akan pergi dekat address line. So dia jalan-jalan. You imagine lah, this is not the correct metaphor but just for your understanding. So dia pergi nombor 6, okay nombor 6 dah sampai dekat nombor 6, dia buat apa guys? Dia kena buat apa? Dia nak ambil kan, dia nak fetch right? So what will happen? Jawab, jadi apa? Dah sampai ni, CPU dah sampai ni. Belum MR, dia kena bawa balik dulu kan, dia kena patah balik ke si? Patah balik, dia patah balik ke mana? Ke CPU, dia patah balik lah ke CPU. Bawa lah nombor 6 tu. So ni tadi bila dah nombor 6, MBR kita jadi nombor 6 tau. So MBR data dan nombor 6. Macam tu. Okay, faham lah? Dia punya ni lah. Tapi depending on the instruction. Katakan dekat nombor 6 tu dia decode. The instruction said, oh you should go to IO. Then dia akan pergi IO lah, dia akan pergi ke IO. IO pun sama, ada address. Sama, yang dapat line-line. Maksudnya address. Okay, faham tak? Okay, contoh. Kita patah balik ke sini. Belum, ini belum. Dia contoh ni bagus. Mana tadi IR saya? Hilang pula. Okay. Sekejap, sorry. Ni belum tadi IR. Ni perkataan unless told otherwise depending on instruction. Kalau kata IO, pergi IO and blah blah blah. Okay, instruction loaded into instruction register. Okay, bila dia ambil, katakan benda itu adalah instruction, dia akan loaded into instruction register or instruction. Okay, processor interprets instruction and perform required action. Baru dia akan interpret. Apa benda yang you nak I buat ni? Macam tu lah. Interpret mean decode. Another word for it is like decode, translate. It's the same thing. Okay, it's the same thing. Okay. Ini boleh baca sendiri, senang je lah. Processor memory meaning is a data transfer between CPU memory. Processor IO is data transfer between CPU and IO. Okay. Kita nak, okay, ni penting lah. This is very important slides. If you can understand this part, kita dah boleh habis kelas. Contohnya lah. Maksudnya kalau you boleh faham this part, for lecture 3, 4, 5, 6, it will be easier. And also for your operating system pun will be easier. So please pay attention for this part. Senang je. Because I already explained the function of CPU and how they communicate to memory. Now kita using an example. So it's a bit more clearer. Okay, you go to slide number. Kalau you boleh scribble. Ini slide nombor berapa guys? 4 nombor slide. Belum. Tell what slide number we are on? 17. Okay, 17 lah. Saya lupa nak suruh you guys print out. Okay, let's start. Okay, let's start with slide number 17. Alright, sekarang ni dekat sini contoh ada dua. Now the communication, the action of data only occur between memory and CPU. Tak ada I.O. tak terlibat. Bukan bermaksudnya I.O. tak wujud, dia tak terlibat. Dalam conversation ni I.O. tak ada. You can imagine I.O. dekat sini lah, I.O. Cuma dalam this example, it doesn't involve I.O. Kita tak ada involve I.O. Jangan dia kata, tak ada I.O. Memang tak ada pun. Tak ada conversation. Conversation is not the technical word. I just said for easier to understand. So, sekarang ni, you have memory and you have CPU here. Pen saya tak bergerak. Okay, now, in memory, CPU, right? So, first, you know what is the function of the CPU. Fetch and execute. Macam kill and execute. Macam fetch and execute. And then memory to hold the data, to hold the program, to hold the instruction. Okay, so first, what should we do? CPU, processor, and remember, so processor must be busy at all time. Barulah komputer you efficient. It cannot be idle. Dia kena sentiasa bekerja, baru dia efficient. Maksudnya macam, dia kena bekerja lah, dia kena cari kerja. Baru dia efficient. Dia must be busy at all time. Tu maksudnya processor yang bagus lah. Alright, now CPU. Kan tadi kan, dia kena tengok dekat PC kan program counter. Dia will look at this address that pointed by program counter. Then you must tahu apa PC. PC to hold the next address to be executed. So, address number 300, alamat. So, dia kata, now I need to go to this address 300 in main memory. So, what should we do? Dia akan pergi ke CPU. CPU will go to memory lah. Dia akan scan lah. There's a method. To scan, there's a method. Yang ni you tak belajar lagi nanti, operating system. Dia akan tengok mana alamat 300 ni. Macam driver Grab awak lah. Dia akan cari awak ke mana. College. You duduk college mana? Ke you duduk kat rumah? Dia akan jumpa, ni 300. So, dia dah go to this address. So, they will brought back this data ke dalam CPU. So, dia akan ambil lah 1940 masuk dalam where? Instruction register. So, you must understand what is instruction register. Tengok balik definition dia guys. Ni. Instruction loaded into instruction register. Instruction akan dimasukkan ke dalam instruction register. Sebab tu kalau you faham dia punya basic, you akan faham semua. Okay, so kan tadi dia fetch kan, so dia akan masuk dalam into this register. Kat sini dia tak keluarkan MAR, MBR. MAR, MBR tu to hold the address and data separately. So dia akan masuk 1940, the whole thing. What's next? Dia buat apa? So yang ini penting. You nampak tak on your left side guys? Yang ini kan? Okay, PCR, ni definition of program counter, instruction register, SC is a storage lah, accumulator, storage, temporary. Yang ini saya nak tunjukkan. So this is a partial list of opcode. Opcode is operational code. Okay, operational code. So apa dia? 0001 is load SC from memory. 0010 store SC to memory. 0101 add to SC from memory. Okay, saya nak tanya what is the value of 001? Berapa value dia in the decimal? Berapa value dia guys in decimal? 1. Okay, good job Faris, is 1. Okay, what about 0010? 0010 berapa value dia guys? Okay, Patrick, 2 good. Okay, what about 1010? 1010 berapa? For the first one. Besar sangat tu Patrick, 10. 1010. Anyone? Ada tak? Siapa jawab? Naim, thank you, it's 5. Okay, 5. For those who are wondering how they get this answer correctly, ni yang you do conversion kan. So 001, let's give example of 0001. Always remember in binary you start with your right to left, kanan ke kiri. When you count, kanan ke kiri. So 1, how they get 1? Is dia panggil base 2. Is it base 2? So we get to the power of 0. Anything to the power of 0 we get 1. Itu. So 1, 2, 3, 4 daripada kanan. So 0, 1, 2, 3, right? So and then how you get 2 is 0, 0, 1, 0 to the power of ni kosong kan? 1, 2. So you get 2. What about 5 here? 0, 1, 0, 1. So ni 0, 1, 2, right? So kosong, anything that you multiply by 0 you get 0. So you don't have to count that. To the power of 2 plus to the power of 0, you get 5. Boleh Siapa yang masih tidur lagi tu, you faham kan how you get this answer? Kan sebab tu dia punya sequence right to left, you kena ingat lah mana yang tak ingat. So, yep. Okay, anyway, so this is the operational code. Dia partial, dia banyak je. So dia dah bagi you kat sini contoh. So now, you dah okay, go back to step number 1. Okay, you dah load into instruction register. So what's next? Remember, CPU, fetch and execute. Dia kena process. Okay, 1940. So this CPU will decode apa maksud code ini, apa maksud instruction ini. So the first digit is the code, is the operational code. So the CPU will translate what number 1 means. Apa maksud dia? So kita akan pergi dekat step number 2. Okay, remember PC will by default increment by 1. Kenapa tak ada berubah? Tadi ke 300, and now your PC increment by 1. 300 plus 1 automatically dia dah jadi 301. Kan 301. So yang tadi ni 1940, so it will translate 1 ni maksud dia apa? So you refer to this partial list of code di 1 kat sini. So dia kata apa guys? Load AC from memory. Dia kata load AC from memory. Okay, 1 maksudnya load AC masukkan sesuatu load AC ke dalam AC dari memory. Okay, you go to step 1, AC is empty kan, tapi they ask you to load something. Load maksudnya you letak something lah ke dalam AC tu. AC tu storage, temporary, you bayangkan dia macam barcode. Masukkan sesuatu ke dalam AC dari mana? Dari memory, okay? Memory where? Where from memory? Memory tu dekat mana dia nak ambil guys? From where? Remember it is addressed by location. Load SC from memory. But which location? Location apa? Location berapa? Cuba. Nah, okay, good one. 940. Sebab operation dia bila dia translate, number 1 said load SC from memory. You must know CPU. If they want to fetch something, they must know the address, the location. So they go to 940. So CPU akan patah balik ke memory, dia akan ambil 940, go to this address. So this is the data. Bila you nampak kosong kat depan ni, maksudnya kalau CPU translate, kosong kan tak ada apa, so it's a data lah. It's not the instruction lah. So dia akan kata load to AC, dia kata ambil daripada location 940, store to AC, load to AC, load to AC. So dia akan masukkan ke dalam AC. So before that, AC is empty, kosong, tak ada apa. So sekarang you load 003, sekarang masukkan 0003. Actually this is the operation of 3 plus 2. Actually you wondering. This is what computer do when you do this simple operation. So okay, tadi kan PC dah increment by 1. So now CPU will go to this new address 301. So they go to step number 3. So CPU will go to 301, this address. Dia akan scan lah, oh this is the address. Masuk address ni 59, so ambil the whole thing, this instruction. Remember at this stage, CPU doesn't know whether this instruction ke ni data, dia tak tahu apa content dia tak, regardless what are the content, dia will fetch it. So dia akan dibawa ke mana? Dia akan masukkan ke dalam instruction register. If you can see now, it's changing. Tadi 1940, now is 5941. Sebab dia adalah register, it's a temporary storage, so it's swappable. Sentiasa akan bertukar depending on what address they are pointing. Okay, so sekarang dah tukar. Jadi is the, what is like now, 5940. 5941. Remember, CPU punya function tadi kan fetch, execute. Fetch, execute. So now dia execute. What executing maksudnya dia akan do the translation and blah blah blah. So dia akan translate the apa maksud 5 ni. 5 tadi apa guys? Code dia apa untuk what operation? Add, dia kata kan. So dia refer, oh ni 5. Add to AC, dia kata tambah to AC dari memory. Oh no, add to AC, dia kata tambah to AC from memory. From which location guys? From which location at memory? In memory, from which, okay, go on. 940, okay, good. 941. So the CPU, mana pen, pen ni geram tu apa pen ni. Okay, dia cari, okay. So dia akan pergi dekat location 941, kan? Dia akan pergi, dia jalan, ni dia kata pergi ambil ni. 000 tu brought back to CPU tapi letak dekat mana? Tadi kan nombor 5, add AC, add to AC. So you know, jangan dia masuk dalam IR pula. Dia kata add to AC, hantar ke AC, masuk tambah ke AC, tambah. Bila tambah ke AC, tadi kan 003, right? Dah ada 3 kat sini tapi kod dia kata tambah 8. So tambah lah, So the existing data tadi 3, so it's add to AC. 3, the operational adalah 8. 3 tambah 2 jadi 5. So dia akan update. So akan jadi 5. At the same time, what happened to PC guys? It will increment by 1. Sekarang dah jadi 302. Simple kan? Setakat step number 4, do you guys can follow? Faham? Okay, thank you. Okay, sekarang dah bertukar. Okay, sekarang Remember, CPU ni kan tadi cycle dia. Start, fetch, execute, then dia berpusing, then baru stop kalau dah habis. So now we go to the next step sebab 302. So kan CPU will look at this address point by PC. Dia akan tengok, oh sekarang I need to go to this address 302. Itulah kerja PC, berjalan je kerja dia kan. So CPU ni, so CPU will go to this address, jalan. Oh ni dia scan, dia kena scan tau. So dia dapat 302, okay. Dah dapat to this address, dia kena bawa balik semua ni yang dalam ni to this CPU lah. Dia nak execute, dia kena dalam CPU, dia tak boleh execute dalam memory. So dia bring back geram betul lah. Okay, dia akan masuk ke sini. Sekarang ni IR awak dah bertukar instruction register. Register ni, kalau you nampak perkataan register je, temporary storage. Sentiasa bertukar. So now dia akan load 2941 into this register kan. So ni adalah what is look like at this stage. 302, 005, 2941. So the CPU will execute. Dia akan translate. Apa ni nak? Apa ni data ke? Is it instruction? Is it data? So dia tengok nombor 2. Oh, nombor 2 dia kena translate. Apa nombor 2 ni? So you tengok balik kod ni. Nombor 2 tadi apa guys? Cuba tengok. Nombor 2 apa? Apa nombor 2? Buat apa? Store. Store lah. Dia kata, okay, store. Dia kata store where? Store AC to memory. Dia kata store AC. Dia kata store AC. AC ni. You pergi dekat AC ni. Si Bizal ni dia pergi ni 0005 ni. Dia kata simpan ke memory. Oh, ke memory. Tapi memory ke mana? What address? Which address? Which location? Di mana guys nak simpan dia ni? 941 good Rebecca. So 941. Okay. Dia kata oh kena simpan, dia katakan simpan dekat 941. Okay. CPU pun buatlah kerja dia. So dia kata store AC kita adalah 0005. Ni ya data awak hantar ke sini dia kata. So the next step will be 0005. So ke dalam main memory. So sekarang 940. Previously is 002. Now kita write. Ni kita panggil write. So dia akan tukar tadi 002 kan. Sebab dia kata store AC to memory. So ni dah jawapan awak dapat di 5. Katakan operational code to say store AC to IO dan dia will store to IO. Ni contohnya, banyak lagi sebenarnya ni, banyak lagi operational code. Tapi dia is the basic operation of addition 3 plus 2. Macam ni lah. This is how it work. Boleh faham kan? Bila tengok 303 dia akan plus by 1 by default. Boleh guys? Cuba tengok. Boleh faham tak? Dia just to show you how CPU function tu je. CPU ambil, execute, ambil, execute. All the data, all the program must be loaded into memory. Dia kena duduk dalam memory. Dia tak boleh duduk tempat lain. Dia bukannya terus dekat CPU. No. CPU kena ambil. You bayangkan Grab driver je. You kan pernah naik Grab. Siapa tak pernah naik Grab? You cuba naik Grab petang ni. Kan? Kalau naik Grab, when the Grab, you order Grab kan, first you must confirm your location, right? This is my location, current location rumah. So when the Grab driver want to fetch you, dia kena tahu apa kan? Apa maklumat paling penting driver tu kena tahu? What's the important information the driver must know? Pandai. Alamat. Pernah tak dia nak tahu awak ni single ke dah berpunya? Ada tak? Kan? Dia kena tahu alamat. Your address and your destination. Sama juga dengan CPU. CPU, they must know the location. How they get the location? They will refer to PC, program counter. Program counter will point to the address to be picked from the main memory. Sama juga. You ingat the metaphor dia driver je. They must know the address of the source and destination. Without the address, they cannot pick you up. Sama juga dengan CPU. Sebab itulah memory ada memory line, and each of the line there's a data, there's instruction, there's a program, and it's will associate with the address. Okay. Sama juga dengan I/O. I/O pun ada address. That's how they exchange the data. Okay. By looking at the address. Okay. Kalau you boleh faham ni, then the rest will be easier. Okay. Point dia sebenarnya, okay, for lecture 2 ke 3 ke 4 ke 5, dia punya basic definition is very important. If you understand the definition, what is the function secara general pun you dah boleh faham. Contohlah kalau you dah faham apa function CPU, then you will understand this easily. Okay, for those yang masih tak berapa nak faham, tak apa, you balik nanti you baca balik the definition and you go back to this slide. Okay. Jadi it's the same thing, the different visualization sahaja. This is a step diagram. Tapi what we have discussed so far, ini dah dia, sama je. Okay, contohnya instruction, this is a CPU one, instruction fetch. Dia will fetch the instruction. Okay, sinilah. First dia akan tengok address lah ya. Dia will look at the address. Dia nak fetch, dia kena ada address. Dia kena simply fetching, cannot. So dia akan fetch, tengok address dulu. So dia fetch the instruction from where? It can be from memory, it can be from I/O, depending lah. So, okay, dia akan instruction operation decoding. So lepas dia fetch, kan dia bawa balik ke CPU, right? So dia will do the decoding. Dia akan translate lah what this data tell us to do. Apa operation, subtraction ke arithmetic ke logic, okay? So lepas tu apa? Okay, for example, if they need, dia bagi contoh daripada ni ya. For example, if they need to get the operand ni maksudnya data, they need to know the address. So they akan calculate the address. Oh, I need to get this data from this address. So the CPU will fetch this data, this operand from that particular location. It can be I/O, can be memory. So katakan multiple operand, meaning there's a few data need to be fetched, tapi dia kena ada address. Okay, lepas tu apa? Lepas tu data operation lah. Okay, just now we give example of addition lah, penambahan. Okay, data operation, they perform the operation, blah blah blah. And for example, they need to store this address or need to write it into I/O or memory. Dia akan need to know where should I store this result, memory ke I/O. So dia akan based on the address. Dia panggil operand address calculation. They calculate where should I go. Okay, based on the address, so they do the operand store the operand. Kalau ada multiple result, dia will go in cycle lah, dia akan pusing-pusing. So then PC will increment by 1, so dia akan bersambung lah. Sekejap, pen ni kan. Tak nampak dia ni kat ni. Dia akan pusing-pusing sampai habis. Sama je. Boleh guys? Dia nampak complicated tapi tak pun. Boleh? Boleh ke tak boleh? Berapa jam perlu sebelum? Okay. Ni definition ni you bacalah sendiri ya. Baca sendiri ya. Kita dah discuss. Sama je. Kan saya baca ngantuk pula kan. Sama je. Ni apa ni mechanism. Oh, okay, now we go to interrupt. So now kita nak belajar sedikit pasal mana ada? Apa Guan think? Apa yang tak ada? No. Apa tu Guan? Tak ada apa Okay, move on Okay, now kita tengok interrupt. What is interrupt? Okay, can you give me the definition of interrupt? Apa maksud interrupt guys? Any definition lah yang you faham. Kacau lagi. Bagi contoh satu situasi interrupt. Can give you any situation at this time. Can give you any scenario yang you selalu hadapi. Kucing kacau tengah makan. Okay, kucing kacau tengah makan. Okay. You are eating makanan, tiba-tiba kucing datang. So this kucing interrupt you from what? Eating kan? So you have to stop, right? Then when you stop, your attention switch to where? Kepada makanan ke kepada kucing? Kepada kucing. So that's how CPU works. Remember CPU, itu saya kata tadi betapa pentingnya simple basic definition. CPU only execute or macam ni apa ayat dia tadi lupa. Dia bekerja one at a time. You only execute one instruction at one time. So now I'm currently running this program. Contohnya the CPU currently running program A, contoh. Then there's the interrupt from program B. So the CPU need to stop whatever program that currently running to switch their attention to program B. Itu maksudnya interrupt. Sama dah situasi tadi, you tengah makan, kucing tengah kacau, you makan kan. Bila kucing kacau, you akan berhenti tak? Then you akan tengok kucing tu kan. It's either you marah ke ataupun you share your food kan. But then, perasan tak you punya attention to switch? So you stop the current apa-apa you tengah buat, then you switch your attention. Kan? Sama juga dengan CPU. Sebab CPU only can execute one instruction at one time. But they are very fast lah. So it seems to us all program happening at one time. But it's not. Okay? Even though you guna dua core, katakan awak core PC, you ada dua CPU, the same concept. It's just that they ada dua lah. Okay? Itu adalah interrupt. Dalam komputer, they give a signal. They will send a signal. Kan signal ni akan di-carry through system bus. Okay, dalam operating system nanti, next semester akan belajar banyak jenis-jenis interrupt dan how it's work. Okay, dalam CA kita belajar sedikit saja. Okay, so dalam CS kita tak akan pergi banyak lah. We're not going to go into that. Definition of interrupt and example of the scenario of interrupt. Okay, it's a signal lah. It's a signal. They send the signal to CPU. Dia akan kacau CPU, berhenti, you kena process this program. So dia kena pause. So dia running program A, so dia akan save context. Dia akan save the information. Okay, kat mana dia tengah running, which address dia stop. Dia go to process, dia will serve process B, the interrupted, dia akan yang interrupt dia tadi tu. After they finish with process B, then they will resume process A. Itu maksud interrupt. Okay. Ini contoh-contoh interrupt program timer, IO hardware failure. So they will receive the signal. Okay. Ini baca sendiri ya. Kita go straight to the contoh. Ini contoh-contoh interrupt. Okay. You ingat ialah pasal kucing dan makanan tadi ya. So this is the normal program A without interrupt. This is a single program in the early system. Sebab itulah early system dia only one program at one time. Dia tak ada interrupt. Dia tak ada multi-programming, kena ada interrupt. Otherwise you cannot do the multi-programming. Okay. So you tengok contoh ni guys. So user program, for example they give 1 to 3 is a program. Ada 3 program. Yep. Pen ni. Pen ni kan. So contohnya, contoh dia execute ni habis. So write ni dia write to where? Dia write to IO lah. Dia write the whatever output lah kepada IO. So dia need IO. So the CPU will go to IO. Sorry ya kalau you nampak scribble tu right. Nampak. So the CPU will pass to IO. Habis program tu habis kan. Dia resume back here. So di proses tu, there's no interrupt. Tengok nombor tu sampai habis. Habis kan. So CPU go to the IO. Sampai habis, there's no interrupt. You tengok 1, 2, 3, dia finish execute. Okay, let's look at contoh B ni guys, nombor B ni. B ni sini kan, interrupt with short IO wait. Okay, for example here, sini, 1, ni tak ada interrupt. Okay, bila dia masuk nombor 2, if you notice it will be what this means. While they are running program 2, while they are running, CPU yang run lah. So, dia kata kena ada X ni. X ni maksud dia apa guys? Maksudnya they receive the interrupt signal. Or they receive the interrupt signal for the interrupt handler lah. Oh dia kata, CPU dia kata berhenti, you need to serve this program. Okay, nampak interrupt handler ni. Okay, the CPU will stop. The CPU will stop running program 2, dia akan stop. So dia akan save all the information about program number 2 ni kan. So dia ada nombor 2 ni. So the CPU Ni. Sini kan sebab dia receive signal dekat sini tau, interrupt ni. Dia berhenti kat sini. So the CPU will go to the different program. Okay, lepas habis dia ada kan, dia akan patah balik. Dia patah balik sini to resume. They need to resume whatever the interrupted program number 2. So they resume. Habislah program 2 ni. Okay, then they need to write lah ke, in this case to IO. Okay, now there's another program to be executed, which is program number 3 kan. So dia akan execute. So CPU ni pun running lah program number 3, running mean that execute lah. So tengah-tengah shock dia running kan, dia dapat in signal. Dia kata CPU, dia kata kau berhenti sekejap, dia kata you need to serve this program. This program maybe have higher priority macam whatever program kan. So okay, the CPU dia tak boleh belah macam tu je kan, dia kena save all the information. So dia akan save the location, dia save the contact, adalah maklumat dia kan, PCB dia. So dia akan berhenti dekat sini. Kan dia dapat signal dekat sini tadi kan from the interrupt handler. Interrupt handler yang bagi signal tau. So dia akan proses program tadi tu yang dia kena serve tu. So lepas habis kan, dekat sini apa CPU buat sama juga tau, dia akan fetch, dia akan execute the same thing. Lepas tu dia akan resume back. Dia akan sambung dekat mana dia tinggalkan. Dia will pick up whatever they left. So sambung sampai habis. Macam tu lah. Faham tak guys? Macam awak tadi, awak tengah makan, you are eating, then suddenly the cat come nearer to you kan. You tengok kucing tu tengok awak kan. Lepas tu is either you shoo the cat or you give the cat some food, then you continue eating. Betul tak? Kan you bagi semua kat kucing tu. Macam tu lah contohnya. Okay, you resume, then you pause sekejap, then you pick it up. Yang lain tu ke tengah makan ni. Am I interrupting you guys? Adik. Macam tu lah contohnya. Itu contohnya. Lepas ni kalau you will not looking at the cat the same again. Bila you nampak kucing, dia panggil dia interrupt. Interrupt sini kan? Macam tu lah. Contoh Okay. Okay. Kita tengok nombor C ni guys. Interrupt long IO wait. Dia sama je konsep dia interrupt juga. Cuma dekat sini scenario, dia give you different scenario. Tapi it's the same thing. Okay, nampak tak user program 1, 2, 3 ni need to be processed by the CPU. So dekat mana interrupt tu berlaku guys? Dekat IO. So mana pen? Fungsi ni jalan. Okay, kat sini okay. You tengok bila interrupt handler tu panggil dia. Okay, kat sini. Dia tak habis lagi tau dekat sini. When they come here, they receive the signal, interrupt signal. They receive the interrupt signal. They send to the CPU. So the CPU need to is interrupted by the IO kat sini. So dia akan proses dulu. Lepas tu dia akan sambung balik. Tengok sini. Dekat sini dia tak habis lagi. So they receive another signal. Kan? So baru dia sini. So they receive another signal. Dia berlaku dekat while they about to write something in IO. Okay, different scenario but the same concept. Okay, basically interrupt tu, the CPU receive a signal from the interrupt handler telling the CPU to stop what they are doing, then give attention to that program. After they finish execute that program, then we resume back the interrupted program. Itu maksud dia. The interrupted program tu maksudnya dua arrow B, dia kena interrupt. Okay. Itu interrupt. Ni untuk multi-programming. Sebab itulah now our system can do multi-programming. Because the CPU can be interrupted. Kalau dia tak di-interrupted, maksudnya dia bukan multi-programming lah. Tapi of course we can set the priority. Which one they need to serve first. Okay. Okay, ni pada jam ni. Setengah dah. Okay, ni tadi, ni apa akan jadi bila ada interrupted. If no interrupt, fetch next instruction. If interrupt, what will happen? Suspend execution of current program. Okay, suspend execution of the current program. Contoh nanti 2. You tengah running nombor 2. Dia kata suspend execution of current program. Save context. So dia akan save whatever dia tengah buat lah. Set PC to the start address of that. So then the CPU need to go to this address sebab dia kena serve program lain. So that PC, kan saya kata tadi, the PC by default increment by 1, right? Otherwise, unless told otherwise. So dia kata increment by 1, dia kena point to a new address yang interrupt dia tadi tu. So you akan start contact of program ni 28 lah. Okay, dia akan process the interrupt. When they set the process, they set the same process, fast execute and whatever, and then restore contact and continue interrupted program. Dia akan continue. Tadi kena interrupt kan, tu continue. Ini semua penerangan in advance. Okay, ni sama juga. Different visualization image. Okay, I plus 1 lah, because masa I macam masa address dia. Tadi you dah buat, nampak tak ni? Kan dia kena interrupt kat sini. So dia kena pergi kat this program. Settle dia pick it up back lah. Okay. Ni contoh cycle of CPU tadi basic one. So now if you have interrupt handler. So you need to add one box here. Sini. Yang ni lah, kena ada benda ni lah. Kalau tak ada benda ni, tak ada interrupt. So this is to check the signal of the interrupt. Kalau you add button. Interrupt cycle sama je, tengok sama je. CPU function dia sama, fetch, execute. Kalau dia nak fetch, dia must know the address, that's it. Okay. Ni boleh faham kan? Tambah sini je. Kalau disable, so tak adalah benda ni. Contoh je. Okay. Ni sama juga guys, different images. Yang ini, yang program timing show IO wait ni sama dengan ni. It's the same thing. Different gambar, nanti lepas ni I nak you analyse sendiri. Tapi sama je guys. Tengok sendirian yang ni Kalau tak sempat habis. Okay, boleh guys buat tengok sendirian. Sekarang ni pun sama tau. The state diagram is the same one, but this is with interrupt. So you kena tambah sini. Itu. Dia akan check, check the signal. Dia akan check ada signal tak. If the signal received, then the CPU need to set the context, stop the running program. So dia akan go to the new address. PC tu address dia akan bertukar kepada address interrupt program yang interrupt dia tu. You need to go to this address. So they will look at the PC program counter. So then do the same fetch, execute. After they're done with that program that has interrupted them, dah habis, they will resume back the interrupted program. Okay, dia akan sambung balik lah. Sama je ni, the same thing happens. Okay, function CPU tetap sama, cuma dia di-interrupt, dia kena pergi ke new address, itu sahaja. Sebab tadi kan by default increment by 1, but when you are having an interrupt, ada interrupt, so you need to go ke situ. Lepas tu baru you patah balik. Then resume as normal lah. Okay. Then you can disable the interrupt. Okay, you can define the priorities. So di sini macam printing, okay, you can define lah. Yang ini kalau you buat hardcode lah. Okay, low priority interrupt can be interrupted by higher priority. Ini simple lah. Ni kita nak tunjuk sequential interrupt. Okay, it can be happening multiple interrupt. Lepas satu interrupt. This is used for program. Supposedly the CPU kan dia in sequential manner kan. 1, 2, 3, 4 dia nak kena buat program. Contoh tadi lepas program 1, program 2, program 3, program 4 proses. The CPU get interrupted. Okay, I need interrupt handler X. Program ni. About to finish, about to resume the program 2, katakan program 2 kena interrupt So there's another interrupt daripada handler, ada multiple interrupt So dia dapat interrupt lagi, dia kena berhenti lah. Dia pilih sini. Later can be anything else lah Then baru sambung 2A, 2B. Ini kita panggil sequential interrupt. Sequential interrupt mean lepas interrupt 1 tu habis, baru interrupt nombor 2 boleh interrupt. Dia bukan di tengah-tengah. Sequential mean one after another. Okay? Now it's nested interrupt. Nested interrupt is interrupt inside the interrupt. Dia macam, tadi saya ikut kucing kan? You tengah makan, kucing tu tengah kacau, datang senada kucing. You tak habis makan lagi, tak habis marah kucing. Dah datang kucing B. Contohnya macam tu. Dia interrupt on interrupt. Macam tu. So, tengah dia proses the interrupt from, katakan kita panggil A lah Ni kita panggil B. While the CPU is giving attention to A. Maksudnya, this program get CPU. So, they got interrupted. Dia ada signal. Okay, this has higher priority. Usually this has higher priority kan. So CPU need to stop from processing A. So dia akan stop dekat sini lah. So A akan jadi AI lah contoh So CPU will go to this program B. So dia akan proses sampai habis. So dia patah balik sebab ni tak habis lagi. So dia will resume. Dia will resume A. So dia akan habiskan. Then they will go back to this user program to continue to resume the interrupted program. Maksudnya kalau you main Uno card macam reverse Uno card lah, power card on power card. Pernah main Uno? You play Uno? Tahu kan? Puan tahu kan? Apa yang tak tahu main Uno boleh belajar dengan Puan. Kan? You nak bagi plus 2 dengan kawan awak, lepas tu dia bagi you draw 4. Okay, reverse balik. Macam tu lah interrupt. Tepung kucing tadi. First kucing tadi tu single interrupt. You baru nak marah kucing tu, tiba-tiba datang kucing lagi besar. So it's multiple interrupt. Macam tu je lah. It's interrupt. You go back to the basic definition interrupt. Itu sahaja. What are you interrupting? CPU. Sebab dia nak CPU ni dia efficient kalau dia busy at all time. Dia tak boleh idle lah. Okay, faham Ini sama, contoh sama, just T is a time. So dia show you the example of at what time is happening. Dekat T10, printer interrupt. So they finish and then at the T15, the printer got interrupt by communication ISR. At T20 is got interrupt. They received the signal from this ISR. Okay. And they finish at T35. So this is the timeline only, but it's the same thing. This is the nested interrupt. And this nested interrupt. Contoh nested interrupt, but they're giving you the timeline. Okay, sama Okay, all we have 30 minutes. Okay, we should be able to finish. Okay, connecting computer component. All the computer component must be connected. Of course lah, kena connected. Different type of connection for different type of component. Okay, different type of cable. Okay. Ini contohnya. Okay, ada read, write, address data. Read, write, kalau you perasan, dia ada read, write, address ni. Now, tengok sini. Instruction, address, data. Okay. Yang lain-lain ni jadi pada sistem bus. From the system bus. So they carries the data. They carry the data. Okay, to exchange between these three main component. Between these three main component. Okay, kita tengok. Okay, memory connection, receive and sense data, receive addresses of location, receive control signal. Contohnya read, write, timing. Ini baca sendirilah. Similar to memory, you find to receive data from computer, send data to peripheral. Okay, output. Dan input from peripheral or from computer. Ini saya nak taklah apalah. Saya nak terus kepada bus Ini boleh baca sendiri. Kita dah discuss. Just that in proper wording you refer to the slide. CPU read instruction and data. Okay, read maksudnya dia fetch fetch. Write out dia akan hantar balik ke memory atau IO. Okay, send control signal to other units. Okay, receive and act on interrupt. Ini CPU punya function Okay. Okay, now we go to bus. Can we have 2 minutes break before we continue with bus system? 2 minit break. You nak minum ke apa ke? Ke ada yang dah tidur lah? Bangun. Bangun. Kita try to finish bus system bus. Okay, I give you 2 minutes break. Then kita akan sambung on the second part of our lecture, which is system bus, system interconnection. Okay. Nanti ada homework sikit guys. Siapa belum scan, boleh scan sekarang? Okay, part is over. Okay, let's kita start balik dengan sistem bus. Okay, jom. Kita selesaikan ya lecture 3 guys, supaya kita tak lupa ni. Dah kenapa? Nampak tak PDF ni? Ke you nampak QR code? It's a PDF, right?
Nampak PDF tu.
Okay. Kadang saya pun tak faham dengan benda ni. Kenapa saya tak nampak PDF saya ni? Wait guys, I need to... Sekejap saya stop sharing first. I need to close the QR code ni. Kacau. Okay. Okay, system bus. Okay, for system bus, you ingat bus je lah. Bus kegunaan dia apa? People ke, livestock ke kan? To carry something. Same goes to your system bus of your computer. Okay. Di komputer awak, Mickey Mouse ni. So, bus akan dekat sini. To exchange data between these three main components. So the bus itself is a main component, okay? Tapi function dia to exchange the data between these three main components. Remember, they're not talk directly, because they're different components. Okay, the communication pathway connecting one or more device. A bus normally has access point. Okay, this pattern again. The bus concept is already common both inside the PC or outside real world as well. Okay, in fact, your home telephone wiring is a bus. Information flows through the wiring that goes. Tak payahlah ni. Okay. Okay, the advantage of a bus that makes bus more interchangeable. Okay, if you want to get a better graphic card, you simply unplug the old card from the bus and plug in a new one. Okay. So, ni payahnya. Okay. Of channel in one bus is depending on the number of bits. Dia punya width, dia punya keluasan, kelebaran. So the more wide, the bigger the width, the more data can be carried. So it's faster. Dia macam bus lah, bus panjang dan bus pendek. Bus panjang, bus mini dengan bus express, which one can carry more passengers? A van dengan bus, which one can carry more passengers, guys? Bus kan? So same goes to the system bus. The big, dipanggil width lah, width lebar tu. The bigger the width, so the bigger the capacity in bits lah. So it can carry more data ke, address, kita panggil data je at this point. So can more be carried to exchange between these three main components. Okay, there's a number of possible interconnection system. Kita ada local bus dengan primary bus. Okay. Okay. Untuk CA ni, kita will not go very technical lah. What is system bus, macam bridge AGP. We just, for me, is focusing on the definition of system bus, how it works, what is the main function. Okay. Okay, the first known as the system bus or the local bus connect the microprocessor, the CPU, at the system bus. G is the fastest bus in the system, so the local bus. Then the second one is a slower bus for communicating with things like hard disk and sound cards. Ini kepada yang secondary storage lah, maksudnya hard disk juga, sound card, any other peripherals. So this is the different type of bus that it used to connect. Okay. It's known as the PCI bus. This lower bus connect to system bus through a bridge. So dia kena lalu jambatan lah. Okay, which a part of computer's chipset and act as a traffic cop integrating data from the other buses to the system bus. Okay. Dia banyak bus lah, type of bus depending on the devices. Okay. Yang connect that through the CPU is a local bus. So it's faster, pendek. Kalau yang lain tu dia kena jalan guna bridge. So dia panjang lagi lah. Ini contohnya, Okay, you can see there, level to cache system memory, front side system bus. Okay, to the I/O, you akan ada bridge kat sini. Jadi kalau kita dekat lab, kita boleh buka lah the desktop. Okay, tengok with the different kind of the system bus. Okay. Nah, dia nampak tak? Ada bridge to interconnect them. Interconnect them. Okay. Every bus is composed of two distinct parts. Okay, data bus dengan ini saya kata tadi data bus dengan address bus. Yang ni distinct part. Ini dia. But they carry separately ya. Then you ambil data. CPU kan dia based on the location. They go to the specific location in main memory. So untuk data, dia akan letak dalam data, bus data. Untuk address dia letak dalam bus address. Macam tu, ikut jenis. Kan? Ikut jenis. So they have different line, dedicated lines for it. Okay? So it's more efficient. Okay, provide synchronization and control that allow the CPU to communicate with memory and I/O lah by two fundamental operation, read and write. Read to get the information, write to write back the result. Okay, data bus, it carries the data. Okay, remember there's no difference between data and instruction at this level. Itu yang saya cakap dengan awak tadi tu, yang saya kata yang dalam memory kan you ada instruction, ada data. When that carries, dia regardless what type of data, instruction ke data ke, dia tak kisah, dia bawa je, okay. But dia function dia bukan decode, dia nanti dekat dalam CPU baru dia akan translate. Dan dia nak, oh ni data, oh ini instruction. Masa dia bawa dia tak tanya pun. Macam tu. Contohlah. And the key determinant of the performance is the number of bit they can carry. The bigger the better lah. Okay, maksudnya dia save the time more efficient. During the read operation, okay, data move from memory or I/O to the CPU read. Okay, move dari mana? From I/O to CPU. Bila dia fetch, dia read tau. During a write operation, data move from the CPU to memory. Bila dia dah execute, you want to produce the output or result, dia akan write back, dia update kepada memory dan I/O. So, kena pandai differentiate between read and write. Pandai differentiate ya. Keliru. Okay, address bus to identify the source or address of the destination. Okay, CPU need to read instruction from a given from a given memory. Data from given location. The bus width determines the maximum memory capacity of the system. Okay, kalau dia ada 16 bit, so giving you 64. Okay, ini ada cara pengiraan dekat sini, you can boleh refer to how to calculate. Dekat sini ada ya guys ya. So just to show you that kalau dia boleh the bigger, the wider the system bus, more capacity, more space they can hold to them, they can carry it. Okay. Control bus. Okay. Control how the bus function, allow user of the bus signal when data is available. Apa control? Signal lah, signal. It's the signal control. Apa signal dia? Read, write, interrupt request, clock signal, timer lah. So it's the control. So dekat data bus ni dia ada 3 line lah. Data, address dan control. So each of this line they carry its own entity. Data, address, control. Okay? Dia tak bercampur. Alright. Ni contoh dia. Control address line. Boleh bayangkan pelbagai jenis bus. Okay? So dia tak, when they do the exchange of data, dia campur. Boleh faham tak? Gambar ni paling penting. This gambar paling penting. Okay, to show you the lines of the to communicate between these 3 main component. Sama je gambar ni, dia bentuk dia lain je. Kalau you buat macam ni, okay, kita gambar macam ni kan. Sama je. Sama. So same thing same thing. Ni, what do buses look like? Contoh dia. Ni saya dah. Ni contoh-contoh kalau dalam desktop yang besar macam ni, kalau dalam desktop is very smaller but the capacity is bigger. Okay, bus width. Ni, okay, now I wanted to give you a simple homework. Okay, cuba tanda guys. Dekat page number 48 ni, apa is ISA? Nanti minggu depan saya nak tanya. ISA ni apa? Okay, ISA, what is ISA? Okay. And then ni metafora ni senang je. The bigger the lane, the faster the bus can go. Macam highway lah. Banyak besar highway tu makin cepat lah kereta boleh bergerak. Okay, contoh tak payahlah. The bandwidth, also called the throughput, refers to the total amount of data that can theoretically be transferred on the bus by given unit of time. How many data can be carried one time? Berapa lama? Per second, let's say maybe 200 kilobyte per second. Okay, unit by time unit. Okay. If the bus width is the number of lane and the bus speed is how fast the cars are driving, then the bandwidth is the product of these two and reflect the amount of traffic that can be channeled and conveyed per second. Is it 200 bit per second? Berapa banyak dia boleh bawa dalam masa in per second or in nanosecond or in millisecond? Okay. Example. Then another homework is in slide number 51. Ini pun another homework. Okay, slide number 51, tanda guys. How they get this value? 15.9. How they get this value? How do you calculate this value? Ayo kena cari. Number 51 Tadi 48. Now is slide 51. Sekarang slide number 53. Benar Okay, boleh 48, 51. You buat panggil nama seseorang Okay, Veronica. Nanti Veronica cakap kat kawan lain. Okay, yang ini saya akan skip. Yang tadi kita dah discuss sedikit. Kalau ada the local bus, they need to have the device to interconnect them. So using the bus bridge, okay. Yang saya skip, please read on your own. Ni dedicated multiplex ni baca sendiri boleh Yang DMA dia just want to highlight. Yang ni dalam operating system kita akan belajar more in deeper. DMX direct memory access. DMA is what you have learned today is a CPU talk directly to main memory, right? So in order to have faster communication, and the CPU doesn't have to go all the way to memory, there's another component that introduced DMA, direct memory access. So the CPU doesn't have to go to the memory. You go check the DMA first. The data is not exist in DMA, then you'll go to main memory. Dia macam cache juga lah. Okay. So dia ada cable yang connect to CPU. Okay. So they don't have to go to the memory. Sekejap saya nak scan which one that needs attention. Ini baca sendiri. Baca sendiri ya, baca sendiri guys sebab dia macam a bit theoretical je lah. Dia tak ada benda yang, it's not that technical. So I do believe you guys can read on your own. Benda ni. Oh ni, okay, another example lah. Another homework is find out what is meant by synchronous and asynchronous bus. Apa maksud synchronous and asynchronous bus? Dia ada bagi hint kat sini timing ni. Okay. Cuba tengok apa maksud synchronous and asynchronous bus. Actually this already the answer here. It just as I want you to make buat research sedikit. Apa maksud dia? Why is it faster than asynchronous bus? Why is faster? Why synchronous buses tend to be faster than asynchronous buses? That's this thing that you need to find out. Kenapa? Kenapa dia bagi this point? All buses are typically asynchronous while the CPU memory bus is usually synchronous. Why? How? Okay. Yeah, synchronous is now. This session is synchronous in real time. Sekarang ni, our session we call synchronous. Sync lah. Real time at the same time. Synchronous swimming. Same time, same thing happens. Asynchronous is not happening at the real time. So first, you cari the definition of synchronous and asynchronous. Then, you cari apa maksudnya synchronous bus and asynchronous bus. Actually, the jawapan, you can get the answer from here, but I want you to do little research. Can try to have your own answer based on the facts, okay? Jawapan semua ada kat sini. Ni dia bagi contoh jawapan based on the diagram. You kena baca lah. Ni ada jawapan semua, ada asynchronous bus, synchronous bus, but I want you to do a research. Baca ni dulu dan research, okay? Jawapan semua ada kat sini. Yang saya skip ni, yang ni tak berapa nak penting sangat. It's just that you must know lah. Bus ni dia still ada control data dengan address. Yang ni just evaluation of the system bus. You boleh baca lah. Okay, I think that's it for today guys. So a few homework need to be done. Okay, tadi what is ISA? And then slide number 51, how do you calculate that value? Then after that, find the definition between synchronous and asynchronous bus. Okay, what makes them different and which one is more efficient? Okay, I think that's it. I will stop here. Before we stop, if any question regarding the lecture or class, ada apa-apa soalan? Ada apa-apa soalan tak guys? Kalau tak ada, okay, that's it. I will see you. Belum ada, so far no. Okay. Hopefully yang tak ada tu sebab you faham Okay, I really hope when you say no question meaning that you understand well. Tapi kalau tak berapa faham, you go back to the slide and read it again. Okay. Okay guys, I think that's it. I see you next week. Untuk tutorial nanti saya akan upload. Okay, tutorial kita tak buat, we don't do it like every week like we have discussed before. So I will pick from time to time, I will pick a few questions from tutorial to be discussed during the class, okay? And then for those who haven't signed the attendance, they are going to share the attendance again for 2 minutes. Then after that, I will close the link. Okay guys, bye-bye.